One of the most common of the acylation reactions involves the acetyl functional group. The acetyl functional group is methylcarbonyl, and substitution reactions that take place here are known as acetylation reactions. Acetylation is a specific type of acyl group transfer in which the acyl group is the acetyl group. Nature has its own acetylation reagent that's known as coenzyme A, or CoA for short, whose structure is shown in this blue box. The A in CoA stands for the adenosine nucleotide, and that's linked to the acetyl group through this thioester bond. The substitution reaction that takes place involves exchanging this thioester bond for another nucleophile. We'll talk about that in the next webcast, but in this webcast what we want to talk about is the biosynthesis, how it is that the acetyl group is put on CoA in the first place. What we're going to learn is the ways in which the acetate group is activated. Acetate is the anion derived from acetic acid, which is the parent of the acyl group. So let's see the three different ways by which acetyl-CoA is biosynthesized. In bacteria, the pathway involves attack of the acetate nucleophile on the gamma phosphorus of ATP. This is done by an enzyme that's known as acetate kinase, and ADP is the byproduct. The result is this mixed anhydride, the acetyl phosphate, structure shown here, which is highly activated toward substitution, the phosphate being an excellent leaving group, and the thiol group from coenzyme A comes in and does an addition-elimination reaction to make the acetyl-CoA group. The second pathway involves attack at the beta phosphorus position of ATP. In this case, the reaction is likely not to be a one-step SN2 reaction as in the previous example, but here it's probably an addition-elimination process. The result is that AMP, the monophosphate of adenosine, is lost, and we end up making a mixed anhydride that involves this diphosphate, acetyl diphosphate. That also is very activated towards substitution. The thiol group from coenzyme A comes in and does an addition-elimination process. Pyrophosphate is lost as the leaving group, and acetyl-CoA is prepared. The third way involves the attack at the alpha position, and it's the breaking of the bond that I'm highlighting here between this phosphorus at the alpha phosphorus and this oxygen atom on the side away from the adenosine unit. So the result is pyrophosphate and what's known as acetyl adenylate. The adenylate unit is connected through this mixed anhydride, the mixed anhydride of carbonyl and phosphorus oxygen double bond, linked through oxygen. That's the structure of acetyl adenylate, and so this entire unit becomes a very good leaving group. That's going to be lost on substitution with the nucleophile from the thiol. The thiol nucleophile will come in, do an addition-elimination process, AMP is the byproduct, acetyl-CoA is the result.